Okay, we're going to look at more challenging binomial problems now and look at the general term to help find coefficients. You'll find from the full expansion to the general term the only difference is the sigma, because instead of adding all these things up, we're just going to find a specific term. So we're going to do the long-winded way first and find x to the 4. So if I were asking you to expand this, then you would know that you're going between 7 and r, and your first term is 7 going down the way, and your second part is going up in pairs. So if I were to do this, then you would have 7, 0, 7, 1, 7, 2, and on and on and on. You'd have 2x everywhere. You would have the minus 3 over x squared everywhere, and you'd go 7, 6, 5, 4, 3, 2, 1, 0, and then 0, 1, 2, 3, 4, 5, 6. Okay. I'm going through this fast because you know how to do that now. Okay, so you'll have all your coefficients, and then you can have the 2x to the 7 expanded, and to the 0 is 1. Then 2x all to the 6 times that to the 1, 32x to the 5. Remember, squaring it makes it positive, and so forth. Okay, so I'm going through this quickly because I know you know how to do that part. Okay. When you collect together, just be careful about your pairs. Remember that will reduce 2x to the 4. That will be just x, and then you'll have indices at the bottom. So you know how to do that. The question at hand said x to the 4. So x to the 4 would have the coefficient minus 1344. And that's how we find the coefficient if you expand it fully. So you just expand it and find out where it is. The next thing that I want you to do is realise that you don't have to know that off by heart. If you know that's in the formula sheet, your actual general term is just dropping the sigma sign. If you do put the sigma sign in, then you will lose marks in a test for general terms. So if you know the general term, how do you find the general term here? So same question again, but a slightly different way. What we're going to do is not put the sigma on and put the 7 in the r, and the 2x with the 7 minus r and the minus 3. So really, actually, the only thing I've not put there is the sigma just now. However, to find x to the 4, you need to get your x's together. So I'm keeping the 7 to the r together. But what I'm going to do is start separating this. So I'm pulling out the 2, but it's still 7 minus r, and then getting the x alone, pulling out the minus 3, and then getting the x alone. I don't like that, so I'm still going to keep going. So what I've got there is the 7r, I've got the 2, and then what else can you do? You can bring the minus 3 over so all your numbers are together, and then have your coefficient x multiplied by the terms, but also at this point here, bring that up as a negative in this so that you can see you're starting to get it all together. What it means is this part here is called your coefficient, and this part here will be the term. So when we're talking about the term, we're talking about x to the 4, and when the coefficient is the number in front of it. So the next stage is we were asked to find x to the 4. So we're trying to find x to the 4. The next step is to find what value r would be, and we need to bring this together. So I'm doing this in a long-winded way just now because you've never seen it before, but that's what that is there. And we want to bring it together as a single term first of all. So that doesn't need a bracket, it's just 7 minus r as the index, the pair. But this here, remember when you multiply, you can have it as to the minus 2r. Multiplication means add your pairs, so you end up with that. The next thing is that we have to find r. So if you remember, it was x to the 4 we were going to find. So what we need to do is set this equal to x to the 4 then. And if you actually have x to the power and x to the power, you can just say 7 minus 3r equals 4. Take 7 off of both sides, and you get r is 1. Now that you have figured out what r is 1 is, what we're going to do is use the coefficient and find it. So you know that the coefficient is written in this format here. When r equals 1, all we're going to do is substitute where it is. 7 factorial over 1 factorial, and the difference is 6 factorial times 2 to the 6 times minus 3. You don't need the power of 1 there. So that's 7 times 6 factorial over 1 times 6 factorial times 64 times minus 3 Notice they cancel and you get your answer. It's the exact same as the one before. You might feel this is awful long just now, but I'm just really breaking it down for you, okay? So let's try one that's easier to get you more comfortable with it. If you were asked for x plus y to the 7, yes, you could expand it fully, but I'm not going to do that here. The thing that's really nice about this is when you've not got x on both of them, actually you've almost got it in a nice set up general term already. So if you put the 7 in, it's actually already achieved being the coefficient and having it separated. There's not actually anything you have to do, so it's quite nice. So this is already step 1, getting your terms together. Then what about the next step? The next step is to solve to find out what R is. So I'm going to do it 2 ways here. So it still seems like a lot because I'm showing you 2 steps. You take your expression and you set it equal to what you want. That means that if you want to focus on the y's, because you've got 2 letters, just focus on 1 letter, then you would just get y to the r equals y to the 4 and r is 4. So I've went for the easiest one first. You might have not done that. You might have wrote your expression, set it equal to what you want, and decided to use the x's. Well, it's okay. You still get the same idea. You get x to the 7 minus r equals x cubed. So that means 7 minus r equals 3. Take 7 off of both sides. You still get 4, so it doesn't matter which one. So go for the easiest. Right, okay, and the last step is to use the coefficient. And here the coefficient is just 7r. So if you know that r is 4, then put that in. That means 7 factorial over 4 factorial times 3 factorial. 7 times 6 times 5 times 4 times 7 times 5 times 4 factorial. Notice the 4's cancel out and actually the 6's, and you get 35. So we're getting more in a flow. You don't have to do that twice. So now I'm going to reduce it down after this one. This one here, x minus y to the 5. Remember to keep the minus there first of all, but you want y alone when you're going to find the expression. So what do we need to do this time? We need to pull out the minus. So if we have minus 1, what we're going to do is just bring it together at the front. So you get your coefficients and your terms on separate parts. Right, so if I wanted to then find xy to the 4, you take your expression and you set it equal to what they ask. If you want to focus on the y's first, then you can see r equals 4 right away. You could just write, so r is 4. If you want to focus on the x's instead, it's still xy to the 4, but if you want the x's, then what you'll find is that you'll get 5 take r equals, and remember that means x to the 1. So 5 take r equals 1, take 5 off of both sides. Again, it's the same, so why not go for the easier one? When you know r is 4, then we can find the coefficient. So then we remember to take everything that's not part of the term part. So we're going to substitute in r equals 4, and we will get 5 factorial over 4 factorial times 1 factorial, and minus 1 to the 4 just turns to plus 1. That's 5 times 4 factorial, and then you know the 4's cancel, and you just get 5. That's it. So I'm not going to do 2 parts this time. I'm just going to go straight to it. So if I asked you to do this one, it's to the power of 8. So that would be 8r, 1 to the 8 take r, and then x squared to the r, following the rule. 8r is just given. 1 to the power of anything is just 1. So I'm going to do that now. And I'm going to use the index rule. And if it's got the bracket there, it means the times. So then you don't need the 1. This will be your coefficient. And this will be your term. What are we asked to do? We're asked to find x to the 6 here. So what I'm going to do is take the term and then find x to the 2r and set it equal to x to the 6. That means 2r equals 6, so r is just 3. This time I'm doing the terms to this side, since that's where I always have it, and I'm doing the coefficient to this side here. So the coefficient is 8r, there's no other thing there, okay, and you know r is 3, so we're going to put r is 3 in. That's 8 factorial over 3 factorial, and the difference is 5. 8 factorial is 8 times 5 8 times 7 times 6 times 5 factorial. You'll see the 5's cancel down. Do you remember what 3 factorial is? It's actually 6, so that you cancel down as well, and you're left with 8 sevens, which is 56. Let's do it again. So if it's finding x to the 4, 1 plus 2x squared cubed, so it's to the power of 3. So 3, the first part's 1, and then we have 2x squared all in the bracket. We need to start moving this around, so that'll be times 1. Pull out the 2, and then the x squared. That is just 1, so I'm taking the 1 away, but I'm going to have the 2 to the r beside it, and then write that as x to the 2r. What were we asked to do? We were asked to find x to the 4, so I'm going to use that and find the term and set x equals 2r to x to the 4. That means 2r equals 4, so r is 2. What do we do then? We find the coefficient, so we go over here and we write down what all the terms are of that. We know r is 2, so we can put it in. That's 3 factorial over 2 factorial times 1 factorial times 4. And then remember that can be written as 3 times 2 factorial. So you can see the 2's cancel out, and you're left with 3 4's, which is just 12. You get that? It's getting nicer now. Okay, a little bit trickier, to the power of 4. So you've got 4r, x to the 4 take r, and 2 over x to the r. Let's start pulling it apart. So that's staying the same just now. I'm going to pull the 2 out and have that as 1 over x to the r. You need to get your x's all together eventually. So what I'm going to do is write this as x to the minus 1, and then pull the coefficients to the front and the terms to the side. So you know you've got your coefficient and your terms. What were we asked to do? We were asked to find x squared, if I just remind you there. So we're going to use the term and set what we have equal to x squared. Let's open this up. So that is x to the 4 minus r, and remember your rules of multiplication. So multiplication means you can collect together, so it's 4 minus 2r there. Then we've got 4 minus 2r equals 2. Take 4 off of both sides, and you get r equals 1. Find the coefficient when r is 1. So we know it's 4r and 2 to the power of r. Let's put 1 in. That's 4 factorial over 1 factorial times 3 factorial. Remember, you can break that down, and then you'll see the 3's cancel down, and you get 4 times 2 is 8. At this point, you'll keep seeing this being positive because r can only be 0 up to the value of n. Okay? Can't be negative and can't be a fraction. So watch out. Right, okay, to the 7. So 7r, and then x to the 7 minus r, and then minus 3. What's your sign? Okay, let's pull it apart. So minus 3, pull out 1 over x, and then do the exact same again. So bring that as x to the minus, and lastly, collect your coefficients together and collect your, if it will open up for me, your terms together. You would ask for x to the 5, remember, so what we're going to do is find x to the 5, set that equal to it. So we can multiply that and have it as times x to the minus r. Remember, multiply means add indices, so it's 7 minus 2r, and then you just solve, and 7 minus 2r equals 5, take 7 off of both sides, and you get r is 1. When r is 1, go back, find your coefficient. So write down your coefficient. When r is 1, we can put 7 factorial over 1 factorial, the difference is 6 factorial times minus 3. You know that's 7 times 6 factorial on the top. And then you know the 6 factorials can cancel, and you get minus 21. So it's getting faster now, the more you get into it. Takes time though. Right, okay, so what have you got to do? You have a variety of sign issues, fractions, and so forth. This is quite a challenge, this part, but it comes up a lot, so make sure that you're happy with it. And you can go to the Scholar pages, and your answers are in 2, 3, 9. Okay.